We're going to take a quick look at partial fraction decomposition here. If you feel comfortable and familiar with it, great. You can jump into some of the other lessons, but if you need to review, come back to this. We're not doing any calculus here. This is just partial fraction decomposition. It's something that you may have covered in pre-calculus, but if not, I wanted to go over it now just so you can be on the same page. So partial fraction decomposition, it's an algebraic property that if the denominator of a function can be factored, then the function can be rewritten as a sum of simpler fractions. So in other words, if I have some function like so, x plus a, x plus b, x plus c, etc. And there's some, it doesn't really matter what's on top as long as the denominator, or as long as the numerator is a smaller order than the bottom. So I'll just throw an f of x up here. This can be written as a over x plus a plus b over x plus b plus c over x plus c. And there's nuance and complications to exactly how it looks, but the idea is we take something that's all one fraction and we can break it into its partial fractions. So let's look at an example to do this. And I'm going to get rid of this because I believe that's what we have in our notes and that's what we'll need to work with a simpler example here. Oh, sorry, it's not in your notes because this is optional. But I'm going to take that out just so it makes it a little bit easier to work with here. You'll notice I can get rid of an x from all of this, and so it'll be ultimately 3 divided by x squared minus x minus 2. That can be rewritten as 3 over x minus 2 times x plus 1. So first we need to get it in this form. Then, because we know that there has to be some a and some b such that the following conditions are met. And this part, there is an algebraic proof for it. I'm not super familiar with it, but if you want to talk about it, we can. Otherwise, just take it as a given that there exists some a and some b such that this is true. That's a kind of property of theory of math. So we're assuming there has to be an a and there has to be a b so that this is true. Now we just have to go about finding that a and that b. So the way that we do that is by kind of starting to try and make these two equations match up, make the two sides match up. So 3 over x minus 2 times x plus 1 is equal to a times x plus 1 over x minus 2 times x plus 1. So I'm trying to recombine these fractions that I have on the right here. And so this will equal 3 is equal to a times x plus 1 plus b times x minus 2. Because I'll factor out or get rid of all the denominators, because now the denominators match, so I can multiply everything by the x minus 2, x plus 1. Now we're quite close to what our a and b values are, and we want them to be true for all x values. So what we end up doing here is we get a little bit clever to solve for my a and b, because a and b should be set up in such a way that this always equals 3. So I'm going to pick x equals -1 to start here. Because I know it has to be true for x equals -1, because it has to be true for all x values. So if I plug that in, I get 3 is equal to a times -1 plus 1 plus b times -1 minus 2. If you'll notice, this ends up going to 0. So now I just have b, and it's easy to solve for b. I get b is equal to -1. Similarly, I can pick x is equal to 2, and then I get 3 is equal to a times 2 plus 1 plus b times 2 minus 2. That second term goes to 0, and I get a is equal to 1. So what that means is that 3 over x squared minus x minus 2 is equal to 1 divided by x minus 2 plus -1 divided by x plus 1. And this is also then equal to what we had written up here originally. So that's partial fraction decomposition. It's just an idea of, we know there has to be some a and some b such that that relationship is true. So we just assume that we don't know what they are yet, and then we solve for them.